tuning in from the depths of Antarctica. The year is 1947. I have not seen civilization in so long. Last I knew, Pythagoras started his cult and solved a right triangle. And I just got onto my Wi-Fi and have found out that you can now find the area of polygons. Now, we have linked the reference sheet that you'll be given on the state test, and here are the three main formulas that we will be covering for today's lessons. So here's a nice little warm-up for you. Go ahead and give these a try on your own, and then follow along as I solve them. So we are given a right triangle here first, and the lovely people that made this said, hey, b equals 5, and c, which is our hypotenuse, equals 13. So all that is left for us is to find a. Now we know that this is a right triangle, so we can use the ever so lovely Pythagorean theorem. I'm going to work over in this area. So the formula, remember, is a squared plus b squared equals c squared. Now we do not know a here, but we know b, which is 5, and we know c, which is 13. So I go ahead and drop down my a squared. 5 squared is 25, and 13 squared is 169. So then moving from there, go ahead and subtract 25 from both sides, and I'm left with a squared equals 144. Remember, to undo a square, you must square root. So in our case, a equals 12. So that is using the Pythagorean theorem. I'm going to go ahead and cut this out of the way and shrink it down to right there so I can move on working with our next problem. So over here we are given a lovely trapezoid. Now remember, for something to be considered a trapezoid, it must have at least one pair of opposite sides that are parallel. And we can go ahead and split up this trapezoid into two shapes. And now we kind of already highlighted these here, but I will just go through it. We have split this into a rectangle, and then we have split this into a right triangle. So in yellow first, I'm going to solve the rectangle. The area for a rectangle or a parallelogram is just base times height. So my base being 20 and my height being 8, I would get area equals 20 times 8. And that equals 160. Now we're not done. We still have this right triangle over here, which I'm going to do in red. And remember, the area formula for a triangle is 1/2 base times height. So my base is 5, and we already know that the height over here is 8. So this height does not change. All along this route here, this is 8, 8, 8, 8, 8, 8, 8, boom, 8. So we have area equals 1/2 times my base, which was 5, times my height, which was 8. Go ahead and plug that into your calculator, into Desmos, into your iPhone 14, and you end up with area equals 20. So my area of the rectangle was 160. My area of the triangle was 20. We have to now combine these together to get the total area. So a simple 160 plus 20 would mean that my total area here is 180. Okay, and now our last warm-up problem, find the area of a circle. Thinking back to, this was about 2 weeks ago, we learned that the area of a circle is pi radius squared, or pi r squared. Now, this is what is pretty neat about circles and squares. You will see a lot of problems given with circles and squares together is if I take the center of the circle, also known as the diameter, this diameter just so happens to be the height of the square that we are given. So we know that the diameter is also 28. But for our area formula, we need the radius. Well, radius is just half of your diameter. So this little guy here would be 14. And now I can go ahead and plug this into the area equation, which would be area equals pi times 14 squared. And I'm going to leave it in terms of pi. So 14 squared would be 196 pi. And that would give us the area of the circle. Okay, now the area of a square. This is some new, ever so important information. And a square is a parallelogram. Think about your hierarchy of quadrilaterals. A square is considered a parallelogram. So this formula will be given to you on the reference sheet. And the area of all parallelograms is base times height. But what is super duper cool about a square is that the base and height are the same length. Remember, for something to be a square, they must have 4 congruent sides and 4 congruent angles. So in our case, all sides would be equal to 5. And then the area would just be base times height, or 5 times 5, also known as 25. So squares, their area formula, quick and easy way to find it. Just remember, all their side lengths are the same. So what if we are, though, given a square and they tell us the diagonal? So let's go ahead and start by drawing a picture here. If I draw a square, that's more of a rectangle. If I draw a square and they tell me that the diagonal, which I'm going to put in blue here, this diagonal cuts right through here. Well, if we knew that this is 90, this is 90, this is 90, this is 90, that diagonal bisects our 90-degree angle. And when it does bisect it, we end up with a 45, 45, 90 triangle. So I'm going to draw the cut part of this. Think about when you were younger and you would make a PB&J sandwich. You cut it right in half to get those lovely 2 triangles, the best lunches ever made. We are now left with 1/2 of that, which would be 45, 45, 90. So back to the problem. They tell us that the diagonal is 7 radical 2. And thinking about our reference sheet, or our knowledge of 45, 45, 90 triangles, we know that both of the legs are the same exact length here. So, if this was given in the form of x radical 2, well, we know that x is 7. So that means this guy has to be 7, and so does this guy. And our whole objective was to find the area of our original square here. So we know that this is 7, this is 7. That is our base, that is our height. So area equals base times height. Well, using Pythagorean theorem or using our 45, 45, 90 logic, we were able to find the base of 7 and the height of 7. So the area is 49.